So this whole unit is about congruence. What does congruence mean? Equal. So congruence means equal or the same. So in order for two shapes, polygons or whatever you have, to be considered congruent, all of their corresponding sides and all of the corresponding angles must be congruent. Let's put it right here, corresponding. Okay, so corresponding means kind of like the matching ones. So the sides that match each other have to be equal, and the sides or the angles that match each other have to be equal. So if we look at this first one here, these two trapezoids, it doesn't tell me that they're equal, but I can look at the lengths and see if they're the same. So if I look at this length of CD, I can just count that it's 1, 2, 3, 4. What's the length of AB? Close. 1, 2. Good. So then I can look at C prime, D prime, and remember from our unit 1, that means that we've taken this shape and we've translated it some way. So if I count this one, it's 1, 2, 3, 4. And then A prime, B prime is 2. So then for the slanty edges, we can count the slope. So to get from C to A, I go up 2 over 1. To get from C prime to A prime, I go down 2 over 1. So those are the same. And then same for B, I go right 1 down 2 to get to D. And then B prime, right 1 up 2 to get to D prime. So then those lengths are also the same. So then we could say that these trapezoids are congruent. So I can say trapezoid A, B, C, D is congruent to trapezoid. And when you're writing a congruent statement, you want to match the corresponding congruent angles to each other. So angle A matches angle A prime. Angle B matches B prime. C matches C prime, and D matches D prime. So I need to say trapezoid A prime, B prime, C prime, D prime. Okay. So the first order doesn't matter, you put it in whatever order you want to. But the second order, you have to make sure that you're matching those angles. Okay. So then if we wanted to list all of our angles that were the same, if we have our statement, we can just match them. So A and A prime, B and B prime, C and C prime, D and D prime. We can also do the sides the same way. So side AB is congruent to side A prime, B prime. BC is congruent to B prime, C prime. So when you have this congruency statement, you can list out all of your congruent parts. Okay. Questions? Alright, let's look at our next one. So this next one, we have triangle DFE and ACB. It tells me I have these little tick marks. Remember, the number of tick marks tell you which sides are the same. So here I could say FD is the same as CA, DE and AB, and FE and DC are the same. And then it also tells me inside my angle, so angle D is 50, angle A is 50, so they match. Angle F is 60, C is 60, they match. What would be angles E and B? What would they equal? 70. Good. So then could I say that these triangles are congruent? Yeah. So then if we wanted to write a congruency statement, I could say triangle DEF is congruent to triangle and then we match our angle. So which angle does angle D match? A. How about angle E? B. Good. And how about angle F? Good. Okay, so the first order you put it in whatever order you want. But then for the second order you have to match them. Okay. So we could have said a different way. We could have said triangle FDE is congruent to triangle, and then again we can just match them. So we already said that F matched C, D matches A, and E matches B. So the first order, again, you can put it in whatever order you want as long as you match it. And then this thing is called a congruence statement. Or a congruency statement, either way. Questions? So another thing you can do with congruent triangles and congruent shapes is set congruent things equal to each other and solve equations. So if we look at this example number 1, we want to solve for x and y. So if I look at x, I've got 7x minus 4. Which side does that match in the other triangle? 31. How do we know? Good. So they both have the 2 little tick marks here. So then to solve for x, we just set them equal. So 7x minus 4 equals 31. And then we just solve it out. So add 4. And then what will be my last step? Good. So x equals 5. Good. Oh. And so you can always check yourself by plugging them back in. So if I plug that x back in, 7 times 5 minus 4 is 31, and that's what we want. Good. So we also want to solve for y plus 8. Which side does it match over here? 24. Good. And again, those have 3 tick marks. So we could say 4y plus 8 equals 24. So how do I solve this one? Subtract 8. So we get 4y equals 16. Good. Divide by 4. So y equals, good. Then again, you can check yourself, plug it back in. 4 times 4 is 16, plus 8 is 24. Any question on that one? Alright, let's look at number 2. So number 2 isn't a great problem because it doesn't tell us that these triangles are congruent, but we're just going to pretend like it does. So we're going to say this side matches this side. They share this side, so obviously it's the same. And then these longer sides are the same as well. So if we want to solve for P, this one is different because it's kind of split. But we don't know that V is in the middle of these sides or anything. It doesn't tell me that. So what I can say is that this entire side, XZ, is congruent to this entire side, WY. So then what would be the entire length of XZ if I know the bottom part is 4 and the top part is 18? 22. Good. So this whole side equals 22. And then this entire side I have 7P plus 13 and I have 2P. So if I add those, then this entire side equals 9P plus 13. Okay. And then I know one whole side matches one whole side, so we can set them equal. So 9P plus 13 equals 22. And then we just solve it. So subtract 13. So 9P equals 9. So P equals what? Good. So divide by 9. And 9 divided by 9 is 1. Questions? Alright, let's look at the triangle inequality theorem. So the triangle inequality theorem says the sum, what does sum mean? Good. So the sum of the lengths of two of the sides must be greater than the length of the third side. Okay? In order for it to be a triangle. So let's say I have these sides here, a pink side, and a blue side. So if I'm looking at these, I can swing these sides around, and they could make a triangle. But if I have a pink side and two blue sides, there's no way that these two blue sides are going to touch. Maybe they will, but we're going to pretend like they don't. So, if you have two sides that are too short, they'll never meet and they'll never make a triangle. So, you have to use triangle inequality theorem to figure out if they can be a triangle or not. So, what you have to do, if you have a triangle A, B, and C, A plus B has to be greater than C. But it has to work for all of the sides, not just one of them. So B plus C has to be greater than A. And also A plus C has to be greater than B. So you want to check all of them. So first we want to know, can the following be lengths of a triangle? So let's look at our first one. So let's just say A, B, C. So I want to add them. So 2 plus 3 is 5. Is 5 greater than 6? No. So that does not work. So this could never be a triangle, sadly, even if it wanted to be. Let's look at our next one. So we got ABC. So our first one, 4 plus 9. 4 plus 9 is 13. Is 13 greater than 15? No. So again, could not be a triangle, because 13 is not greater than 15. Let's check our next one. So we've got 10 plus 5. So that's 15. Is 15 greater than 7? Yeah, so that one's good. But we gotta check the rest of them too. So next we have 5 plus 7, which is 12. Is 12 greater than 10? So then just one more to check, which is 10 and 7. So 10 plus 7 is 17 greater than 5? Yeah. So this one could be a triangle. Let's look at our next one. So our next one, we've got 9 plus 2. Which is 11. Is 11 greater than 2? Yeah. How about 2 plus 2? Is 4 greater than 9? No. So just because the first one worked doesn't mean they're all going to work. Okay. Now one shortcut, you could add the two smaller sides and make sure that's greater than the biggest side. And then that will always tell you yes or no. Questions? Okay. Alright, so our next one, we want to find the range for the measurement of the third side. So to do that, we want to start by adding them, like we did. So 5 plus 6 is 11. And then you also want to subtract them. So 6 minus 5 is 1. So then we have to be greater than 1. Hold on. So we would say that our x has to be greater than 1 and less than 11. Okay, so that's how you write your range. Because anything that's less than 1 isn't going to work, or greater than 11. So let's look at our next one. So for 3 and 8, we do 3 plus 8 is 11. And then we do 8 minus 3 is 5. So then our side has to be between 5 and 11. So then 7, we add them, so 10 plus 4, 14, 10 minus 4, 6. So then we have to be between 6 and 14. So then how about 8? What do I need to be between? So what's 7 plus 12? And 12 minus 7? 5. Good. So we need to be between 5 and 19. Question.